This is part 8 of section 5.1. Now we're going to talk about the end behavior of our polynomial functions with the end behavior theorem. For large values of x, either positive or negative, the graph of a polynomial function will resemble the graph of its leading term when the polynomial is written in standard form. Note that this leading term will be a power function. In calculus, we'd say the value of f becomes larger or smaller as x becomes larger or smaller. And in the case of f of x equals x cubed, we'd write f of x approaches negative infinity as x approaches negative infinity, and f of x approaches infinity as x approaches infinity. In addition, another notation involves using limits to convey this idea. And there you have the limit notation. So, what are we saying here? We're saying if you have a polynomial function with a whole bunch of terms, 2x to the 5th minus 3x to the 4th plus 3x squared, blah, 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 that the graph of that function will resemble the graph of that first term, 2x to the 5th, when it's written in standard form, with the highest one first, like that. And that term is a power function, because remember, those are monomials. Okay, so let's just look at this table, help us sort things out here. If the degree is even, remember what those all looked like. They had that parabola shape, just got a little flatter on the bottom as n went up. And they were steeper as n went up. Steeper as we went out, and flatter on the bottom as we approached 0. If the leading coefficient is positive, well, that means that, remember, if the leading coefficient is negative, what does that mean? It means that, and we'll see that here, it flips over the x-axis. So if it's positive, then as y goes to positive infinity, y will go to positive infinity as x goes to, wait a minute, I think there's a typo here. F of x goes to positive infinity as x goes to positive infinity. And then, as we can see here, let's see. No, it's positive in both directions. This is correct. Sorry. Okay. I'm just not thinking it through right. Okay. Our y's are positive infinity both directions, right? Whether we're going to negative infinity for x, y is still going to positive infinity, or positive infinity for x, y is still going to positive infinity. That's what this says. That's our end behavior, what's happening on the ends. Okay? If our degree is even, we have our parabola shape, and our leading coefficient is negative. That just means it flips. Now y is going to negative infinity. No matter what x is doing, y is going to negative infinity. If x goes to negative infinity, so does y. If x goes to positive infinity, y goes to negative infinity. Okay, that's all we're saying here. Now let's look at the odd. Okay, if it's odd and positive, so no reflection. Remember how that looked? That y equals x cubed looked. So what are we saying? Well, y goes to negative infinity when x goes to negative infinity. You can see that happening. And y goes to positive infinity as x goes to positive infinity. That's this part. Okay, and then of course, if we flip the whole thing over the x-axis because the leading coefficient is negative, now y is positive as x is negative, y is negative as x becomes positive. So that's just a summary of the end behavior that we've seen. Let's look at example 10. Okay, find the zeros of a polynomial and state its end behavior. All right, so for this polynomial, we're supposed to list the zeros and their multiplicities. I like to just make a little table with the zeros and their multiplicities, and then we'll talk about what happens at the x-axis. What's happening there? Okay, so what are the zeros? X plus 5 is a factor, negative 5 is a 0, it occurs once, multiplicity 1. That is, I'm going to make a note, an odd number. So at the x-axis, what does it do? Crosses, right? Odd means crosses. The next one is -1 because our factor is positive plus 1. Multiplicity again is 1. That is odd, and I know odd means that the graph crosses the x-axis. Okay, the next one is x minus 2, so the 0 is 2. It has a multiplicity of 2. That's an even number, and therefore we know that it touches at 2. And finally, x minus 4, that means the 0 is 4. It occurs once, that is odd, and odd means it crosses. Okay, so what would the end behavior be for this polynomial? So what they said was, if we multiplied this all out and put it in standard form, descending powers on the variable, what would be the first term? Okay, so our f of x, which we can also call y, would be equal to, this is the end behavior. The end behavior is going to be like the first term in that polynomial if we expanded it out, the leading term. So if we expanded this out, what would it be? What would the leading coefficient be? Well, if we multiplied this times this, we'd have an x squared, and then we multiply these two, that x minus 2 times x minus 2, we'd have an x squared, and then we have an x squared times an x squared, and that'd give us x to the 4th, and then we got to multiply by this one, so we get x to the 5th. Is there a coefficient other than 1? What is a? A would just be 1, so y equals x to the 5th. This would be our first term. That's the first term. If you multiplied that all out, you'd have x to the 5th plus blah, 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 blah. Something x to the 4th, something x to the cubed, whatever. But the end behavior is just that first term of the expanded polynomial. If there had been some number like 3 here in front, a would be 3, I would have a 3 right there. All right, now it says to sketch the general appearance of the graph using an idea of end behavior. Okay, this is x to the 5th. It's odd. Its leading coefficient is not negative. So remember what the basic parent that we looked at, y equals x cubed, did this, right? It went to y goes to positive infinity as x goes to positive infinity, negative infinity as x goes to negative infinity. So this one will do that also. But it does all this other stuff too. All right, so I'm just going to do a general sketch of my polynomial. What do I need? I need these zeros. So let's see. This is my y-axis, my x-axis. Here are my zeros. So I've got to have a -5. 1, 2, 3, 4, 5. Here's -5. I've got a -1. I've got a 2 and a 4. Right? I could figure out where it crosses the y-axis, but I don't really have to do that. So what I do need to know then is, since I know that the end behavior is going to be like this, on this end and that end, I don't have to do that table. Remember the table we did before to figure out were we above, were we below? Now I know that as we approach this first 0, we're doing what on the end behavior matches this. So I know we're below here. I know we're above here. I've just got to figure out what's going on in here, right? I'm going to use my pencil in case I make a mistake. All right, so I know I come up from below because it has to, this is the end behavior, come up from below to -5, but what do I do at -5? I cross, okay? So come up from -5 and I cross, and then I've got to come to -1. I don't know how high I go, it doesn't matter. I'm just trying to get a sketch. And at -1 I also cross, and then at 2 I touch, and then at 4 I cross. Now I just arbitrarily how low I went there. I don't have any other points to graph. But here's what I know. I know on this end it's going up, on this end it's going down. I use my odds and evens to know whether to cross or touch, so I didn't need to figure out that between here and here I'm above, between here and here I'm below, between here and here I didn't have to do that table. because I understand end behavior and what happens at the zeros when using their multiplicities. Okay, so that's just, I could have also calculated my y-intercept, and if I could plot that, I could have plotted that. That would have been maybe a little nicer thing to do. But we're just supposed to get the general appearance of the graph, and we've done that using the idea of end behavior. Okay, we will continue in the next video.